All right, welcome everybody to Standing for Truth. My name is Donny Budinsky, and in this video, I am going to be discussing the human chromosome 2 fusion, an argument that is quite popular among apologists of common descent, guardians of evolution, that kind of evolution that says whales, pine trees, human beings, strawberries are related through common ancestry. Not that kind of evolution that simply means small scale changes or basic adaptation or change over time. As I like to point out, we don't disagree with changes in allele frequencies in populations over generations. We observe change. Change is real. When we examine the kind of change that is taking place at the genetic level, what we see are horizontal changes rather than the kind of vertical changes that are required to take fish to fishermen, to take goo to you, to take bacteria-like organisms to biologists over time. And so guardians of that kind of evolution, large-scale evolution, they commonly point to the chromosome 2 fusion argument as a powerful piece of evidence suggesting that human evolution is true. And in this short video examining this argument, I want to show everybody exactly why the chromosome 2 fusion argument doesn't matter. It really has no weight to this debate. It doesn't help to move the creation versus evolution debate forward in any meaningful manner, because it is largely agnostic to the overall debate. Whether there was a fusion or not does not provide proponents of human evolution with the kind of argument that they are hoping that it does provide them. And I want to go over several reasons why here in the. Okay, let's start off with this significant point. If there was a fusion, let's say hypothetically there was a fusion in the human line, because even proponents of evolution will admit that the fusion would have had to take place after the hypothetical split. What evolutionists believe is that humans and chimpanzees share a common ancestor, that chimpanzees are our closest cousin, and that we can be traced back to a common ancestor roughly 6 million years ago. And after this split, at some point in the human line, they are not as detailed as I'd like them to be, because typically questions that I have for them, I've debated this topic numerous times with numerous different apologists of evolution, and they don't have much information in regards to answers to the story. How long after the split did the fusion take place? In what lineage did it take place in? Was it in an Australopithecine? What hominin? Was it in early Homo, in the early Homo genus, Homo habilis, perhaps? And how did this unilateral mistake become fixed? Why, even if there was a fusion, it doesn't matter for the overall debate, especially for evolutionists, is because they lack a good explanation for how this unilateral mistake, because that's exactly what it is, could have been fixed. Now, this would have been a near extinction event. Why it would have been a near extinction event is because the person that would have experienced this. Now, the issue is your great apes have 48 chromosomes. We have 46. That's a discrepancy in chromosome numbers. And so after the split, it is proposed that there would have been a fusion. And therefore, the hominin, as they refer to it as, the hominin line, which we belong to, now has 46 chromosomes. But the thing is, every single human being today has 46 chromosomes. There's no subgroup on the planet. There's no tribe that has 48 chromosomes. No, this fusion has become fixed where every single person has 46 chromosomes. And as far as I know, every single human being that we have in the fossil record, so-called ancient human beings, like Neanderthals, Denisovans, they also have 46 chromosomes based on the DNA data that we have for them. And I would predict that other so-called hominins, which are fully human, like Erectus, Hobbit, who is Homo floresiensis, found on the island of Flores, and Homo naledi, for example, I would predict that they, if we get their genetics, also have 46 chromosomes because they belong in the human Baraman, the humankind post-flood. These are all post-flood people groups. Anyways, the problem is this person who experiences this unilateral mistake, this chromosome fusion, this would have been a near extinction event. They would be the originator, essentially, of that fusion. They would have to be the founder of all extant people who have 46 chromosomes. That means all other tribes, all other people, all other individuals and groups at that time would have to be wiped out. That's why this would be a near extinction event, because every single human being today has 46 chromosomes, meaning in the past, any person, any individual, any tribe, any people group that had 48 chromosomes, they would have had to been wiped out. How did this take place? You would have not just all in one big area, so-called hominins or human beings at that time. You would have people broken up into different tribes, isolated from each other. So apparently they're supposed to all get wiped out, and all that's left are human beings with 46 chromosomes. Well, that's difficult for the evolutionary community to explain without a little bit of imagination mixed in to that recipe. But we as creationists, we have essentially two bottlenecks. We have the flood bottleneck, which comprises 8 people: Noah, his wife, their 3 sons, Shem, Ham, and Japheth, and their 3 wives. And so hypothetically, you could have had a fusion. It's just manifestation of genetic degeneration is what fusions are. They do take place, so we can't deny the existence of fusions. A fusion could have taken place shortly before the flood, and those with 46 chromosomes could have been on the ark, Noah's family, and therefore the 46 chromosome signature is passed on to every single person post-flood. Or there could have been a fusion after the flood, shortly after the flood, because people don't spread out to all parts of the globe until the Tower of Babel event. Okay, and that's not for 100 or more years later. And so you'd have faster rates of fixation during that time. We know that the population grew fast, but we don't necessarily know how fast. We don't know if it continued to accelerate or possibly it slowed down a little bit at the Tower of Babel. And we also don't necessarily know how large the population was at Babel. And so there's no reason why fixation wouldn't have been fast for that short time period. Matt, we're going to release an article soon where Matt ran some numbers through AI largely and discovered that the numbers in terms of fixation rates work in our favor, the young earth creationist favor. So that fusion could have been fixed prior to the spreading out at Babel, or even if it wasn't completely fixed, whatever people groups after the Babel dispersal that had 48 chromosomes, it could have been the minority. They could have been wiped out. They had no reproduction in their lineages that were significant enough for the 48 chromosomes to be passed on. There's a number of scenarios in the creation model that can explain how this fusion flourished, become fixed, stuck in place where it's 100% frequency. Every single human has 46 chromosomes. That's the norm. Okay, but in the evolutionary model, how do you explain this near extinction event? One person gets it, but you don't have, like the creation model, everybody like at the Tower of Babel congregating in one large area, or you don't have a bottleneck with 8 people. You have people groups spread out. You have more than just 8 people. You have tribes. There's not necessarily random mating, because you probably have people mostly intermarrying and having kids within their own tribe and their own group at that time. And so very difficult to explain how that could become fixed. And so this is why the fusion is overall agnostic. We also know that there's a paper that I cite frequently that shows a lack of heterochromatin, specific type of heterochromatin that's just densely packed DNA, largely comprises repetitive sequences such as satellite DNA. We don't find this kind of DNA around chimpanzee chromosomes, including the chromosome 2. And so that's another piece of evidence that would suggest that if there was a fusion, it would have happened primarily in the human line, but it's unrelated at all to common descent or human evolution. And that's a problem that the evolutionary community is continuing to struggle with. I want to share a screen here real quick and show everybody what we mean by a fusion and continue explaining why it doesn't really matter. So right here, you'd have the prediction, the evolutionary prediction, where you've got the separate ancestral chromosomes. And then you have a fusion event where two chromosomes would come together. They've got it labeled 2A, 2B, and therefore in the middle. So your end caps of your chromosomes are telomeres. Telomeric DNA is what you'd find. Those are like the end caps of your shoelaces. They degrade over time. They become shorter, and that's similar to how the ends of your shoelaces, they degrade over time. They flare out. And so these would come together, and therefore we should find telomeric DNA basically in the middle of these chromosomes. Now, I've done extensive presentations on the fusion, and this video is not meant to recap all of that. And so what I can do is recommend people type in to YouTube, Donny Budinsky, chromosome 2 fusion. You can find the several debates that I've done on that topic. Impromptu debates. I know what the critics are saying because I've directly engaged them. I've informally debated Dr. Dan Stern-Cardinal on it. I've debated Ian Chen on the fusion twice. We discussed it at great length. But this is the video I highly recommend. Human Chromosome 2, a comprehensive examination. I did this presentation and interview on Brian from Apologetics 101. I did it on his channel, and it was thorough. Went into all the necessary details, and so I do recommend people check that out. And you can also just type in chromosome 2 fusion debate, and you can see all of the debates that I've had over the years. Surprisingly, I forgot about this one until it popped up after looking this up just a few minutes before starting. I debated 5 years ago speed of sound on the fusion. So going back 5 years, I've consistently debated skeptics, some of the most popular skeptics as well of young Earth creation. For example, Gutsick Gibbon, debated her 5 years ago. We discussed the chromosome fusion for 30 plus minutes. I've debated formally Grayson Hawk on the fusion, and I've done informal debates with Grayson and also Mark Reed. Here's a formal podcast debate I did with Grayson. Anyways, all of that to say, I know what the critics are saying on this issue. And if, as creationists, we are going to continue using an argument that says there wasn't a fusion, which I'm not totally opposed to, we need to be as up to date as possible on this issue. And what I mean by that is we do have some good evidence suggesting that there may not have been a fusion. But again, even if there was a fusion, it's no help to the evolutionary model, as I just explained. It doesn't matter at all. As a matter of fact, if there was a fusion, it's easier explained by a biblical creationist from the creationist starting point. Now, if you're a creationist, whether a professional creationist or a non-professional creationist, just outside talking to skeptics, and they might bring this up, people curious, we need to be as up-to-date as possible, because we do understand the basic argument that says, okay, the so-called fusion site, which is roughly 800 base pairs, they have these interstitial telomeric repeats, TTA, GGG, CCC, TAA, but that so-called fusion site is overlapped by a functional gene, the DDX11L2 gene, and that is a functional non-coding RNA gene And supposedly the fusion site acts as a promoter, a second promoter, if I remember correctly, for that gene. And so how do you get highly functional genes? By slamming together two chromosomes. And so we're familiar with this argument. And the critics do have some responses to the functional nature of the DDX11L2 gene. For example, they'll say that the gene is just spurious, low transcription. I've looked it up in the database. I go over this in my presentations, and it's clear that it has function, but because it's non-coding, it doesn't have to have the same level of activity as a protein coding gene. And so it's just a fallacious argument, really, to say that the gene is non-functional because it has low activity. There's many parts of my car that have a lot of activity that are more important, such as the engine, versus some parts of the car that have lower levels of activity. I don't use them as much, but they're still important. They have some significant use, like my rear windshield wipers, for example. My front windshield wipers get a lot more use than my rear windshield wipers. Doesn't mean that the rear windshield wipers have no use. Okay. There's also some features that have a benefit, that have a function, that are nice to have, like a backup camera or navigation, perhaps, or some of these built-in safety mechanisms. But a person may opt out from utilizing those. Well, it doesn't mean that they're non-functional. It means that they're not as functional or necessary for the health of the vehicle as, let's say, the engine. We also know that that gene is expressed in many different cells in the human body, and that the DDX11L2 gene, you can look this directly up in the database yourself, it's important for healthy cell functions. We also have discovered directly in the conventional literature that these internal telomeric repeats that you can see, TTA, GGG, CCC, TAA, they're found all throughout the human genome. And many of those sites have been discovered to be performing functional roles. For example, one of those roles involves binding to transcription factors, which cause or initiate a gene to begin to be copied into RNA. So these are functional DNA units. They're not only found at the so-called fusion site. But here's where the creationists need to be up to date. These are the basic arguments suggesting that there may not have been a fusion. But evolutionists have fair follow-ups. They have challenges that need to be engaged. They're good challenges. And those challenges are, okay, well, yes, we do find those internal telomeric repeats, these interstitial telomeric repeats, scattered throughout the genome. But they've said the fusion spot in the chromosome 2 is the only spot where we find those telomeric repeats. Again, it's TTA, GGG, CCC, TAA. We only find those in a head-to-head organizational pattern in mirror form in the so-called fusion location, the purported fusion spot. Why don't we find, if this isn't a fusion, why don't we find the head-to-head organizational pattern in that high density? They're found in high density. Why don't we find those in any other chromosomes? What I've discovered, unfortunately, is many creationists, they're not as up to date as they're supposed to be on this issue. Because yes, we can point out that, okay, we find these interstitial telomeric repeats, they're functional, they're performing functional roles scattered throughout the genome. But the evolutionist, an informed evolutionist, is going to follow up and say, sure, okay, we agree with that, we concede that. But why don't we find them in a head-to-head manner in the degree of density, the high density nature of the fusion spot? And that's in many ways where the debate ends, because now the creationist doesn't have a response. Dr. Jeff Tompkins, he's done a lot of great work on this, but as far as I know, he hasn't put out any articles, papers, or videos addressing that follow-up challenge. But it is an important challenge, and it's a fair point. And so we as creationists, we need to have a response if we are going to go with the argument that says it's not a fusion. Again, you can just say that it is a fusion, but it doesn't help the evolutionists, because the creationists, as I said during the first 15 minutes of this or so, the creationist has a better explanation for how that fusion could have become fixed in the population. And so allow me to screen share again real quick and show you the density of this spot. And so you have TTA, GGG, CCC, TAA, and you've got them in mirror form, head-to-head, in a head-to-head organizational pattern, and in high density. And so the question is, why is this the case? Yes, we find those telomeric repeats scattered throughout the genome. You can see this has been done in creationist papers where you find them scattered throughout the genome. But why don't we find them in a head-to-head manner? Well, the follow-up is Chris Roop and I, we had an active research project, a short research project where we tested Gutsick Gibbon's challenge that said we don't find these head-to-head telomeric sequences anywhere else other than the chromosome 2. Well, we discovered many instances where they're found in a head-to-head manner, and we list those chromosomes here. But the most significant signature that we find is in the chromosome 9. And so here's the chromosome 9. You can look at it yourself, and you can see TTA, GGG, CCC, TAA. In a head-to-head manner, there's, I believe, 9 pristine repeats. And we also have the fusion, the so-called fusion spot in this article. So I do recommend people check out this article. And so you can point in and say, well, we do find these interstitial telomeric repeats in other chromosomes, specifically the chromosome 9, and it's even more pristine than what we find in the chromosome 2. They're found in both forwards and in reverse. And so here's the facts. We find the repeats in many chromosomes with a large signature in chromosome 9, in both forwards and in reverse. These signatures have nothing to do with an ancient fusion, as in these other chromosomes. No one is going to say that those are due to an ancient fusion. Coffee time. The part where the repeats, TTA, GGG, CCC, TAA, meet head-to-head is actually more pristine in the chromosome 9. We found 9 hexamers in a head-to-head array. So these signatures are not only unique to the chromosome 2. Now, the next follow-up, though, and that's the thing about the chromosome 2 fusion argument, is it gets technical real fast. It's follow-up after follow-up after follow-up with informed evolutionists. Then they'll say, okay, fine, we find those telomeric repeats scattered throughout the genome, and we also find them in several chromosomes, specifically the chromosome 9, a large signature, probably the second largest from what we discovered compared to the chromosome 2, which is the largest, the most dense. We find them in a head-to-head manner. The follow-up is, well, why is it so dense, though, in the chromosome 2 spot? We find them in high density, and we find them in varying degrees of density in other chromosomes, with a fairly large signature in chromosome 9, but still low in density compared to the chromosome 2. So now there's a follow-up challenge that we need to address. They also like to ask the question, well, if I remember this argument correctly, the DDX11L family, gene family, they're typically found next to telomeres or subtelomeres. So why do we find the DDX11L2 gene in the human chromosome 2 near those telomeric repeats in the so-called fusion spot, which would be closer to the middle of the chromosome 2 rather than being at the end next to telomeres or subtelomeres? So there's a couple follow-up challenges, and they're fair points, and we need to address them. And I've done videos addressing those in detail. This video is not meant for me to address those in detail. For example, the argument that says, well, they're found in higher density in the chromosome 2. Okay, That's relative compared to what? Compared to other positions in the genome where they're found in varying degrees of density, these functional stretches of DNA, these functional units of DNA. Perhaps the high density nature of the chromosome 2 spot is connected to the function of the DDX11L2 gene. Okay, these are possibilities. Perhaps the DDX11L2 gene, I mean, it didn't name itself the DDX11L2 gene. And so perhaps based on the chromosome 2 fusion starting point, perhaps the evolutionists have decided to call that gene DDX11L2, assuming that it's part of that gene family when maybe it's not. Okay, there's a possible answer. But these are all worthy of discussion. And the point is the discussion gets technical really fast. But if creationists are going to choose the argument that says there was no fusion, then we want to make sure we're as up to date as possible. And that means looking at the most up-to-date research available. And that would consist of our chromosome 9 work here. And therefore, when a critic presents that argument and says, well, we may find these interstitial telomeric repeats scattered throughout the genome, but we only find them in a head-to-head manner in the so-called fusion spot, you can show them the chromosome 9 data. And we have it here. We have it color-coded where you can see that connection. You can see that there's a lot of these sequences, but not as many as we find in the chromosome 2. And what I point out here is that the apologists of common descent, they want to focus on the high density nature of the purported fusion site, which means they have lost half their argument, because now they're admitting, okay, we do find them in a head-to-head manner, but why are they so dense? And Ruhif, he's also, to his credit, done some good work. He's focused a lot on the chromosome fusion argument, and perhaps he and I can have a discussion on the issue. But why I no longer believe the chromosome 2 point or argument requires these 2 to 4 hour debates, and I've engaged in many of them, probably a dozen, with many different proponents of evolution, some more prominent, Dr. Dan Stern-Cardinal, Gutsick Gibbon, Ian Chen, who's been in the debate community for quite a while, Mark Reed, Grayson, Snake was right. I've debated quite a few on the fusion, and many of them for hours. My podcast debate with Grayson went over 3 hours on just the fusion. And so we want to be as up to date as possible with what they're saying, because the fusion argument doesn't really matter. It's agnostic. What I mean by agnostic, I've said this many times, but for people that might be new to the channel, if I were to say creation is true because the sky is blue, you'd say, if you're an evolutionist, you'd say, well, you're crazy because evolution can also explain why the sky is blue. Evolution is true because the earth is round. Us creationists would say, well, us creationists could also explain why the earth is round or the grass is green. There's agnostic points to the overall origins debate where many different positions can account for the data. What we want to focus on is called discriminatory data. Not non-discriminatory data, but discriminatory data that can help advance this debate in a meaningful fashion. A piece of evidence, an observation that only one model can explain, that might even preclude the other model. Okay, as I like to focus on arguments such as the Y chromosome dissimilarity between humans and chimps, when you consider overall architecture, size differences in gene content, the 2 chromosomes, the Y chromosome is paternally inherited, lacks recombination for the most part. It's less than 30% the same. I might argue that that is discriminatory. Okay, perhaps we could look to orphan genes which lack no real consistent hierarchy. Perhaps the origin, the ultimate origin of those essential functional orphan genes, perhaps that's discriminatory. Or mutation rates, or genetic diversity, or these chicken and egg problems, such as DNA and DNA repair enzymes, or the DNA to RNA to protein complex. Perhaps these arguments are discriminatory, where only creationists can explain the data on the age of the earth, C14 in diamonds, C14 in coal, helium and zircon crystals, dinosaur soft tissue, collagen found in these fossils claimed to be millions of years old. These are all arguments that a creationist can use and say, okay, these are discriminating points where the evolutionary model really lacks a good rescue device. They might have a rescue device. We're dealing with worldviews. Both positions have a worldview. And so we're all going to be faced with a data point that's going to require a rescue device. It depends how good that rescue device is. Is it an acceptable rescue device? Is it a reasonable rescue device? Or is it too far-fetched and imaginary to consider? And so the fusion argument in general, if there was a fusion, there's many reasons why the creationist model can explain it better, but okay, the evolutionists required a fusion because the great apes have 48, we have 46. So if there was a fusion, then at least they have that point. We can't really look to the discrepancy of chromosome numbers as a discriminating point, but we can point out that, hey, in the creation model, we have these two bottleneck events. We can explain the fixation of it. As a matter of fact, we lack heterochromatin around chimpanzee chromosomes, including the chromosome 2, suggesting that, okay, even if there was a fusion, it has nothing to do with human evolution. Or, very interestingly, there's some points that suggest perhaps there wasn't even a fusion. Now, Ruhif, as I was saying, he's put out videos with what he believes are counters to what I'm saying here on the chromosome 9 data. He's acknowledged the chromosome 9 and what we find there, but he's offered reasons why it doesn't really matter for their model. And okay, we could discuss those points, but at least the debate is moving forward in a meaningful way. We're not still stuck on the basics of the argument where we're pointing out interstitial telomeric repeats that are binding to transcription factors, these proteins, which initiate a gene to begin to be copied into RNA, DNA to RNA to protein. Okay. No, we're showing that even their follow-up challenge has an answer. Now the critics are beginning to engage our answer to the follow-up challenge. And so that needs to be discussed. But it's also important to point out that it's just agnostic to the overall debate. Here's some points on the density argument. The rescue mechanism assumes the telomeric repeats are indeed characteristic of an archaic fusion incident. But if one assumes correctly that these are functional units of DNA, the density of the area is not a challenge. Protagonists of evolution still can't explain why the reputed fusion site is exceedingly degenerate. Now, how they do attempt to explain it, firstly, in my experience, they disregard a prominent paper where the authors actually said, why is the area so degenerate? Which means it wasn't predicted, because they'll follow up and say, well, it had to be degenerate. Those telomeres had to be degraded because the telomeres actually work to prevent fusions from happening. So they would have had to been degraded. They would have had to been worn down for a fusion to even take place, for a fusion to even be possible. Okay, that's a fair point. But why isn't it more symmetrical, the fusion, if both were to be worn down or degenerated equally to become fused, for that fusion to be possible? Or why wasn't it predicted ahead of time? Why were the authors of this prominent paper, which I cover in my presentations, why were they shocked? Why were they asking the question, why is the area so degenerate? Here's a few possible reasons. Why didn't they say, well, the area is degenerate, but this is what we expected? These are just some points of discussion to consider. These are some points that can be interacted with. At the end of the day, though, I want to go back to what I said at the beginning. The chromosome 2 fusion doesn't matter. It doesn't really do much to advance the debate, because regardless of whether there's a fusion or not, both models have explanations for accounting for it. While I would argue that the creationist has the easier time explaining its prevalence in humans today, where all humans have 46 chromosomes. The site itself is small and insignificant. One can say that, it's dense in terms of other areas within the human genome and human chromosomes, where these interstitial telomeric repeats are found in a head-to-head manner, they're dense in comparison to those. But what do these regions mean? Do they have functional significance? Are they active in connection with nearby genes? Or is it dense compared to chromosome fusions? Because now one could respond by saying, well, no, it's not dense compared to what a fusion should be. Perhaps a fusion should be 1,000 plus base pairs, maybe even 5,000 to 10,000. We found fusions in other animals. I did a whole video on, if I remember correctly, it was a while ago, a pig fusion that we found that was very high density. We knew for a fact it was a fusion. There's no way around it. Whereas these points are interesting to discuss. I would say there's probably about a 70% chance there's not a fusion, 30% chance there is a fusion. But because maybe there's a 30% chance there is a fusion, we shouldn't be completely dogmatic on the issue. We need to entertain the idea that there could have been a fusion, but that it wouldn't be a problem for a biblical creationist to explain. We don't have the multiverse. We don't have Earth 2 and Earth 3 and Earth 4 where we can compare the chromosome 2 area, the purported fusion site and the high density nature of it, to other chromosome 2s in human beings and other universes. To say, oh, okay, here's a universe where there was a fusion, and look, there's 10,000 base pairs versus this one that's got less than 800. So this one isn't a fusion. Or other observations that we could actually make. That's why I say it's relative, because it's dense, sure, but compared to what? These repeats are found within other chromosomes that aren't nearly as large as chromosome 2. Internal telomeric repeats are found in varying degrees of density, with the chromosome 2 location comprising the highest density. But since these internal telomeric repeats simply represent functional DNA elements important to the operation of the cell, the chromosome 2 location is only high density when compared to other instances of these internal DNA elements, which is why it is relative. It is also no surprise that the so-called fusion site comprises more of these elements, since the location itself is a hot spot for genomic activity and function. And so the high dense nature of this area could have a connection to nearby genes and functions associated with it. If we were to assume this location within the human chromosome 2 was actually representative of an ancient fusion event, the area should not be considered high density, since it is far too corrupt to be a fusion signature. The density argument is arbitrary. It is, as a matter of fact, relative. Okay, these are my, in many ways, preliminary thoughts to this challenge. The whole point is, if we are going to take the route, because as creationists, we can say, okay, how do we engage the fusion argument? Well, you could point out the points that suggest there's not a fusion, but you should be ready to interact with follow-up challenges, including why is that area so dense compared to other areas? But also knowing that we do have other chromosomes, like in the chromosome 9 that Chris Roop and I discovered. Chris ran the analysis using BLAST, where we have these internal telomeric repeats in a head-to-head manner. Okay, now we need to engage the question, why is it so dense? These are my preliminary thoughts. This is how I would answer it. Other creationists that want to continue saying that there wasn't a fusion, or they prefer that argument, then you can either utilize how I've answered it, or you can come up with your own sophisticated response. I think the easiest explanation in a debate, just to move forward and begin to interact and engage discriminatory points that actually matter in the origins debate, I would say just point out the fact that, hey, this is an agnostic point overall. Both models can account for it. And as a matter of fact, the fixation of it, the prominence of the 46 chromosomes in humans, creationists have a better explanation. And that way, you and the evolutionists can move forward and begin to discuss points that matter more, points of higher significance, rather than spending 2 to 3 to 4 hours on these points suggesting that there may or may not have been a fusion, because it'll be a never-ending debate. Because as we can see, we answered the challenge that, hey, we find these telomeric repeats, TTA, GGG, CCC, TAA, in other chromosomes. Here's a interesting signature in the chromosome 9. And then their follow-up question is, okay, well, why is it so dense? And then we can answer that. And then there will be more follow-up questions and the debate will continue. And that's okay. It's fun. But we just want to be as up-to-date as possible on this issue in order that we're not using the introductory responses to why there may not have been a fusion, but not knowing how to respond to the follow-up challenges to those arguments or to those points. Okay, I'm going to wrap this program up with this paper here, the Ventura paper. Chimpanzee and gorilla chromosomes differ from human chromosomes by the presence of large blocks of subterminal heterochromatin, thought to be composed primarily of arrays of tandem satellite sequence. So again, even if there was a fusion, there are many reasons why it's unrelated to human evolution at all. For example, the differences here in heterochromatin. Where is that heterochromatin around the chromosomes of the chimpanzee if there really was a fusion, or if we really do go back to a common ancestor? And so I have quite a few slides on this issue, as I've given extensive presentations on it. Notice this: if there was a fusion, it is what's called an apomorphy, since it is a trait observed in a single lineage. It is only observed in the human line. Apomorphy, a novel evolutionary trait that is unique to a particular species and all of its descendants. What does that mean? Okay, according to the evolutionary model, you got humans, you got chimps. They can be traced back, according to them, to a common ancestor roughly 6 million years ago. There's a split. Chimpanzee line goes one way, human line goes the other. In the human line is where this fusion is purported to have happened. Where, when, how, why, those are questions that the evolutionist needs to answer in detail in order to have a sophisticated and complete model, a model that I think is reasonable in explaining how this occurred and the fixation of it. So the point is, it happened in the human line. And so we as creationists would say humans and chimpanzees are unrelated. And so sure, fusions can happen. They have happened in nature. And so there's not really any significant reason why there couldn't have been a fusion in the human line. And that's why I say overall, this is where I'm going to wrap things up, because the point of this video was what? Why the human chromosome 2 fusion argument doesn't matter. There's better points, better arguments on both sides that need to be engaged, that need to be discussed. It's overall agnostic to the debate. If anything, it might be a good idea to discuss in detail, which I did with Ian Chen in an informal debate for a couple hours. We discussed, okay, assuming there was a fusion, which model can account for it better? And I strongly believe that the Creationist model can account for it better. But hey, here are several reasons why there may not have been a fusion. These are interesting. Let's discuss them. Let's consider them, but also understand the fact that overall it doesn't really matter. Fusion or no fusion, it has no real significant weight on the ongoing origins debate. And so, okay, I hope everybody enjoyed this shorter impromptu video on the fusion. And if you like this content, make sure to hit that like button, hit that subscribe button as well. Hitting like helps the algorithm, and also hitting subscribe. We got plenty of material and content and scheduled events for you guys to enjoy in the future. You're not going to want to miss out on those.